Hello everyone, my name is Daniel Chestnut, and this is my lab partner.
I'm Adam Kimball.
And this is our final project for ECE 3710, microcontrollers. For our project, we chose to design an autonomous robot tank capable of performing object avoidance using a proximity sensor system.
The goal of this project was to create a system that would receive an input and produce an output. So for our system, we used a sensor here at the front, which would receive an input of a distance based on an audio signal. It would also send out that same audio signal. And for a secondary output, we also have the movement of the tank based on the signal that it receives. On the top of our robot here, we have our power source, which is going to take 2 of these 3.7 volt batteries to use as power, which is going to power our entire project. As we see here, it's connected to the microcontroller board here, just our standard STM32 board that we used all lab.
Down here we've got a breadboard here connected in the middle. That kind of connects a couple different components together. Here on the front we have the ultrasonic sensor, which is the key part to the object avoidance ability that this robot's able to perform. It's connected here in the back, and those wires are threaded up to the microcontroller. You'll also see we've got 2 different buttons here, one in the front being a green start button, and the red one behind it is the red stop button. To the right here, you'll see our motor driver. This part was a key component for being able to control the motors and the different directions that the motors would turn. So that was an essential part as well. Down here on the bottom, you'll notice we've got 2 different DC gear motors. These are 6 to 12 volt DC gear motors. We chose these motors because they provided a lot of torque for the project, which we found to be essential as well. We want to talk a little bit more about how the ultrasonic sensor works. So this right here is an example sensor that we had. The sensor has a transmitter and a receiving terminal. And then on the bottom here, we've got our voltage, which takes 3.3 to 5 volts. It has a trigger, an echo, and a ground. We want to show a little bit more of how each of those parts work. And so essentially the way it works is your microcontroller will send a 10 microsecond pulse to the sensor module, and the transmitter will send out in response 8 40 kilohertz audio signals. And so those signals will be sent out of the trigger terminal. Those will sense an object, bounce back, and be measured at the receive terminal. And that period of time where that signal is transferring or traveling there and back is called the echo time. And so what we did is we used that echo and multiplied it by the speed of sound and then divided it by 2 to get our distance in centimeters one way.
So to explain a bit more about the motor driver and how the motors work, here's an example of what the motor driver looks like, since you can see it better here. And to explain it, on each side here, we have these 2 terminals which control motor A on the right and motor B on the left, since there's a front and back motor on our tank. Here's where it receives its power. There's a 6 to 35 volt in, the ground, and then it can also do a 5 volt out. Then here's where it connects to the microcontroller, and this is how we drive our tank. The microcontroller will send signals. These 2 pins control the direction of motor B, and these 2 control the direction of motor A. And based on how the pins are set, we can invert them to change the direction, and that is how we drive our tank. This one can go forward, this one can go back, and that's how you turn the tank, or both can go forward, both back, and that's how it drive forward or back or turn.
So just to show you an example of it going just around one object, right now I'll push the green start button. We'll see it navigate around the object going left, and then it will proceed forward to the other side of the room. So pressing start here, you'll notice it senses the object, turns left, goes around, turns right, goes forward.
Okay, so for our second scenario, we're going to have 2 boxes here. The robot's going to go sense that there's an object, try to turn left, it'll sense there's another object there, and so it'll proceed right. And of course, the time before it turns right, it's going to sense if there's another object there to make sure it's clear. And right now it's programmed to sense that there's an object at a distance of 25 centimeters, so that's why it'll stop there and then proceed. So we'll see that now.
We wanted to showcase another example scenario Essentially in this case, it's going to come up, sense an object in its front, turn left, sense an object to its left, so it's going to check right, see there's no object in its way going right, it's going to proceed right, and then it's going to check forward, see if there's any object in front of it before proceeding forward. It's going to sense there's another object there, so it's going to turn right once again, proceed forward, check forward, see if there's any object. In this scenario, there won't be an object in its path, so it can continue forward towards the other side of the room. This is essentially just showcasing that if there's a wall in front of it, it'll proceed along the wall until it finds an opening, and then it'll proceed. Okay? Checking left, see there's an object, proceeds forward, check forward, there's an object, proceed forward, see there's not an object.
In another example here, we're going to show that the robot has a bias. It'll always check left first before checking right. We're going to show that here we're going to have two objects. You can proceed, see there's one there, turn left, go forward, then check to see if it's clear to proceed forward again. It's going to sense that object, go left again, and it would keep doing that infinitely until there's an opening. We're going to see that here.
All right, this time we've given him a little bit more challenging of an obstacle course. We've combined two different object orientations. We have one being this setup where you have that left wall and then a front object. Should go around those and then have this front object navigate around that one. So let's see how it does. And it proceeds to the other side of the room. We're thinking an improvement we could do is adding additional sensors to the front to create more of a half circle field of view instead of just the one sensor, because the sensor has about 15 degrees of view that it's able to actually see. So in this scenario, whereas we have an object slightly to the right of it, it's not going to sense this object because it's outside of its field of view, and it's going to end up hitting it with its tires because the tires come out at this angle like this. So if I proceed forward, it's not going to see that object.
One error that we ran across is if there are three objects oriented in a C shape like this, what will happen is the robot will proceed in, he will sense there's an object to the left, and then turn and sense there's an object to the right, so he will proceed back out the way he came in. He'll do a 180, turn around, and go back into the same spot. We'll show that now.
See, it doesn't quite handle it very well. This is an area that we wanted to improve and work on a little bit more.
So in conclusion, we just want to go over it again. The purpose of this project was to make a robot for us that could cross a room and avoid all the obstacles. We wanted it to be fully autonomous as well. And we took an input from the sensor and created an output of how the movements of the tank.
Yep, some potential changes we considered just going forward. If we were to go back and do the project again, we would add probably 2 additional sensors on the sides here on the left and right. So that way it would be able to have kind of a half circle field of view, kind of like we described earlier. And that would make it so it would be able to avoid objects a little bit more efficiently. It would also optimize our algorithm a little bit as well. We also considered it would be fun to include a Bluetooth mode, so just eliminate these physical buttons entirely and just have a Bluetooth remote start and stop button instead, so the user would be able to just control it from their phone. We also talked about pre-programmed paths. It would be kind of fun to be able to implement in the Bluetooth app, is make it so if you select go in a triangle shape, it'll go in a triangle shape. Same with going in a square shape, circle, whatever kind of pre-programmed path you wanted to do. You can make it do that. So in summary, we felt like our project was a great success. It's not perfect, room for improvement, but we did a great job.